So it's beginning to look a lot like the last session of the day. So welcome back, everybody. If I may ask everybody standing in front of the doors to just come a bit closer. Take your seats once again. We still have a few spots free up here. The VIP section up in the first row is almost filled. Make your way over, because once again, this is our last and final session, and it'd be great if we could have the same attention we had as we did in the first session. I know it's been a long day, but especially these young talents deserve all the attention they can get now. Where are the young talents here in the house tonight? Hello? Are you listening? Yeah, where are the young talents? Yeah. Say hi. Hello. You're so shy. Really? All right. Anyway, great to have you with us. Also, everybody joining us now remotely, thank you for being back here for this session. Again, it's all about space for talent. And space companies face intense competition, as you can imagine, for STEM talents from tech giants like Google or Amazon, Microsoft, Apple, and so forth, as well as industries like finance. And the space industry's high demand for STEM students clashes with a limited talent pool. So in this competitive landscape, addressing the talent matter requires understanding the expectations and motivations of the new generation. How space companies communicate with them and involve them in space development plans is crucial to overcoming challenges and ensuring the next generation has a voice in shaping the future of space. So this last session will also be divided into 3 parts. We're going to start it off with a panel, then another panel, including our talents, and then followed by a final keynote. So I'm going to start it off with our first guest here on stage. Let's welcome with a big round of applause, Janelle Wellens. Welcome, Janelle. She even got the intro music for the session. There we go. That was actually my fault, but that felt good, didn't it?
Yeah.
She's an MIT alumna with a Bachelor's of Science in Aerospace Engineering. She previously served as an operations engineer at NASA's Jet Propulsion Laboratory, contributing to missions at Saturn, the Moon, and Earth. And currently, she is a flight director at a private space company in Tokyo, Japan. Beyond spacecraft operations, she is an avid adventurer, exploring not only the planet, but the universe, as she says. When not immersed in space activities, you'll find her enjoying the outdoors, experiencing diverse cultures, delving into fiction, playing video games, watching anime, and appreciating the depths of our oceans and sea life. Wow, talk about active, huh? Janelle, great to have you with us. Why don't you take a spot?
Oh, thank you.
Thank you. And we'd also welcome on stage here, Frederico Just. Welcome, Frederico.
I don't get the music.
He's missing the music. See, I thought so. All right. Frederico is an Italian and Luxembourgish engineering professional. He began his career in 2019 as a systems engineer, progressing to his current position as missions operations manager and project controller at iSpace Europe. With an academic background in aerospace engineering, he has diverse professional experience in robotics, telecommunications, and aviation. Frederico played a key role in iSpace's M1 mission operations, operating from the Tokyo and Luxembourg mission control centers, where he sent the company's first commands to space and the last command to Hakuto R as it approached the moon. Frederico, great to have you with us.
Thank you.
And why don't you take your seat?
We can stand up.
All right. Start it off, Janelle, and I'll be back afterwards.
All right, thank you. Oh, did I hit the first slide?
Yeah, try and click. We do have something to show you, we promise. Just not coming. Excellent. All right.
Oh, okay, pretend you didn't see that. All right, hi everybody. Thank you so much for coming out today, attending this talk. Today, Fede and myself are going to be bringing you behind the scenes of the Hakuto R Mission Control Center and telling you the story of what it was actually like to be operating our company's maiden voyage to the moon. It's truly an incredible story, so I'm really excited to be able to share that with you today. But first, we're going to start with some introductions. Introductions of us, introductions of our company, and then we're going to dive right into it and let you know what we have planned going forward at iSpace. So a little bit about myself. My name is Janelle Wellens, and I'm a spaceflight operations engineer at the Tokyo base of iSpace. And just to give you some background on myself, I was not one of those students who thought that I would be doing space one day at all. It just so happened to take a class when I was going to MIT and decided that, aerospace engineering kind of sounds cool. So I decided to go that route, and when I graduated with my degree, I decided to go and work for the NASA Jet Propulsion Laboratory. Now, while I was there, I had the opportunity to work on extremely impactful missions, like the Cassini mission to Saturn. I worked on the Lunar Reconnaissance Orbiter, and I also had the chance to work on quite a few Earth missions as well. And after 6 years there, I decided to take the leap and join a startup all the way out in Tokyo, Japan, to be a part of iSpace's first mission ever to space and to the moon. And it was there that I got to serve as a flight director for that mission, alongside my colleague, Fede, who will tell you more about himself.
Thank you, Chanel. Wow, my goodness, the energy. OK, I'm going to try and match that. I can't promise it. But great to be here. Thank you so much for having us today. So my name is Federico Giusto. I'm an engineer and manager at iSpace Europe. And I joined the company in 2019, so it's almost 5 years now. But I did move to Luxembourg a long, long time ago for some of you, 2008, actually. It's been a long, long time. So I pursued my secondary education here. And I ended up getting nationality as well in 2018. So I pursued eventually my higher education in the UK with a master's in aerospace and aeronautical engineering. And then I returned to continue my career here in Luxembourg. In fact, most of my early career has been taking place in Luxembourg. So I had experiences in Amazon Robotics before they moved to Kirchberg, actually. They were in Clausen still. And also in SES Satellites with an internship in telecommunications. Together with this, I also have short experience in General Electric aviation in the UK. So in 2019, I joined iSpace as a systems engineer, and I was able, since then, to basically work on all of the company engineering products, including the landers and the rovers. And for the M1 mission, actually, that's something I hold very, very dear and close to me, because I was basically in from the very beginning of the development life cycle of this lander, from design, concept, all of the procurements, the manufacturing, the assembly, integration, everything, the testing, and eventually culminating in the launch and ops. So this is, as many of you that work in space today in this room can understand, it's a luxury. It's a luxury for this industry to be able to see the entire life cycle of a project. So I'm extremely grateful and proud that I was a part of this. And in M1 specifically, with Janelle and the rest of the team in Tokyo, I participated and served as a spacecraft controller. So, or also known as pilot. I was very, very clear with my dad to make this distinction because he was an Air Force pilot during his youth. And for decades, he kept telling me all the stories and boasting that he was a pilot. Finally, he admits that I'm a cooler pilot. After two decades talking about it, finally, there is a family win for me. So more of his iSpace. Thank you very much. I look forward to more in the next years.
Yeah, we'll hear more from Fede just shortly. So next, I want to just tell you a little bit more about iSpace as a company. Who is iSpace? I won't assume that everyone in the room already knows. So I love that line there, expand our planet, expand our future. Our CEO, Hakamada-san, started this company, and he started with a vision. He wanted to see a future where we could contribute to a cislunar ecosystem, where we use the natural resources found on the moon to enable us to go beyond. And not only go beyond to places like Mars as well at lower cost than ever before, but also to sustain a human presence on the moon as well. That's people living and working on the moon. It's a huge vision, a huge goal. And he was able to take this concept of having a vision and turn it into a reality with Mission 1 by launching it. I mean, that's incredible. As part of the business model of iSpace, there's these 3 core services. One, we're a transportation company. So basically, customers can send their payloads on our lander to lunar orbit or to the lunar surface. Then we also are able to get them back all of that amazing data from the mission. And last but not least, we offer partnership opportunities for marketing too.
So we actually were founded in 2010, And as of today, we have more than 200 employees of about, and I believe about two-thirds of them are engineers with many, many nationalities. This is something that resonates quite well with Luxembourg, the international ecosystem and collaboration. So I feel like iSpace embodies that very well. We're split into 3 core offices, the Tokyo one in Japan, the Denver, Colorado one in North America, and the one here in Luxembourg, so the Europe office. The Tokyo one is our bigger one currently. It's about 150 people and still growing, and is working on the Series 1 lander that just took part in the M1 mission, as well as the variant of a Series 1 lander called Resilience that will take part in the M2 mission next year. The Denver office is working on, so there are about 80 people, if I'm not mistaken, right now, and still growing. They're working on the next generation of our landers. So the larger version of it, called Apex 1.0. This will be able to take 300 kilograms of payload capacity to the lunar surface, so you can see a significant increase from the current Series 1, and contribute basically in fulfillment to the NASA CLIPS mission in partnership with Draper and other industry partners. Whereas for Europe, we were funded in 2017, and actually I do have another slide just for us. I know I'm biased, but it's the best office out of all of them, so I'm a little bit biased, but please look at this team. How can you not be, right? So this is some of our team members here. We work in the Paul Wurth Incubator, close to the train station, and as of today, we are about 30 employees, still growing. Our primary objective and our primary work on a daily basis is to deliver the company's surface, basically robotic machinery, which is, of course, the rovers. We have a rover that will fly on the mission next year, the M2 mission, called the Micro Rover. We're going to go through it in a little bit, but also the future roadmap of the company. So future rover products that will undertake more complex and more daring missions in the future of the company. So we've been supported by the LSA and the European Space Agency since the very beginning, setting up the company, looking over the project life cycle, supporting through technical leadership. So this is a collaboration we really hold dear, and we wish to continue for a long time. So thank you again.
Absolutely. So now we're going to dive right into it. Mission 1. I mean, it's actually almost the 1-year anniversary. I realized this actually earlier today. December 11th, 2022. That's the day that we launched our first ever mission to space. And I could tell you, it's a moment that I'll never forget. Fede, I don't know how you were feeling.
I'm still thinking about it.
Oh man, it's like you have this culmination of all of these people, hard work over many years, culminating into this event where you can see your lander in the payload bay of a SpaceX Falcon 9 in Fort Canaveral, Florida, ready to go up there into space. I mean, this was such a special moment for our team. And to be a part of that was incredible. And of course, we also had our customers as well, and the payloads, which I have pictured up there. I won't go through them all, but it was a very incredible first mission for our company. And what I really love about it is that we laid out these milestones. So you don't forget about all the hard work that got into getting us just to a landing opportunity. We have 10 milestones pictured here. And I just wanted to note that the first milestone is being ready for launch. And what does that actually mean? It seems like a very small thing, but it's actually so huge. You have to design the lander, right? You have to build it. You have to test it. You have to assemble it, integrate it, all of these things. This took a lot of time, a lot of work by a lot of people. And just to get to milestone number 1, to be ready to launch an actual spacecraft is a huge deal. And we got there. And we launched and had a successful launch. Fede was there for the launch, were you not?
I was still thinking about it indeed.
Yeah. And in our first mission, we were able to accomplish 8 out of 10 of those milestones, which is no small feat at all. And today, we're going to take you through what that meant for us and our team.
So, and beyond the milestones that you just mentioned, we also achieved, it was really a mission of firsts. Yeah. We achieved, for a privately funded mission, we were able to achieve some magnificent milestones. So, for instance, we were the first entirely privately funded commercial mission to reach the moon. So we performed LOI, so lunar orbit insertion, in March 2023. Yep. And to even see the moon coming up, that's not something I will forget very easily, let me tell you. We were also the first privately designed lunar lander and the first such lander to be assembled, integrated, and tested in Europe. More specifically, this was in Lampoldhausen in Germany. I definitely butchered that, I apologize. But anyway, it's with our partners of Ariane Group in Germany. We also became the first commercial mission to be serviced by ESTRAC to actually go to the moon. And if, in case you don't know, S-Track is the ground station network by the European Space Agency. We also beat 2 space records, which again, I boasted with my dad until exhaustion. So we became the furthest traveling and longest duration commercial deep space mission ever. So furthest traveling because in our furthest point, we were maybe 1.4 or so million kilometers away, and we were able to command and control the spacecraft. And then furthest duration as well, as we operated the spacecraft for 135 days in space. So from the very beginning to the very end.
Yep.
And for Luxembourg, last but definitely not least, we had a very big milestone too, because we were able to deliver the first lunar-rated mission control facility in the country. So of course there is mission control facilities already existing in the country, but for deep space missions, this is the maiden one. So we were able to build it, deploy it, and utilize it. And this is something that we look forward to working more for the next mission, M2 and beyond.
Absolutely, Fede. A mission of first.
And that's enough talking already, don't you think? I think we should just
so.
put a video. Yeah. So we have a very brief video to summarize in some visuals, what it really felt like to be part of this historic mission. And then we will take you after that into some more of the details. But for now, please do enjoy.
Let's play.
3, 2, 1, ignition.
iSpace Series 1 lunar lander is now on its way towards the moon.
Never quit. Lunar Quest.
That was our CEO Hakamada-san saying never quit the lunar quest. Oh man, that video brings back memories. I don't know if you caught it, but Fede was in that video. He's in the mission control during the launch.
Working hard, thinking hard, yeah.
So let me start you where, I guess, my journey at iSpace started, which was here on a TV screen displayed in Tokyo, Japan in our Mission Control Center. And that's because when I joined the company, the borders to Japan were actually closed. So I couldn't join my teammates who were there in the room doing the work. Instead, I was calling in at 2:30 a.m. from my parents' kitchen with them sleeping in the background, and me just trying to contain my excitement as we're going through our initial critical operations rehearsal with the crew here. And clearly, I wasn't the only one either. There are other people on that screen too. But eventually, Japan's borders did open, and when that happened, we were joined as a team united. And I love this picture here because when you look at it, it really just explains that global company that Fede was explaining earlier. In this picture alone, I spot the UK, Spain, Belgium, Israel, America, of course, Japan, Hong Kong, India, Thailand. Did I miss anyone?
Probably.
Oh, probably. But it's a lot, right? And you would think that all these people coming from so different places and so different backgrounds, I was from NASA, we had some people from ESA, some people from Lockheed Martin, that maybe we wouldn't actually get along or anything. And how are you going to make this group of people who are so different come together? But it's actually quite crazy what having a mission like this can do. When you're able to unite a team like this with one common goal to make history, it's incredible the results you get. And those differences actually, I think, contributed highly to our results.
100%. And indeed, so just to add on to this, we also had a facility in Luxembourg where we contributed to the M1 mission. And, to say that we were excited and proud to support, this was, it's just an understatement. We were so proud that we got to work on this facility, get trained to the same level of standards and rigor as the Tokyo colleagues. This really resonates with what the company is trying to do. This global mindset, multiple cultures, multiple schools of thoughts, multiple backgrounds. Even just in this picture, you can see there's 4 of us, but there is 5 nationalities. So how's that even possible? So we have Slovenia, the US, Australia, and then Luxembourg and Italy. I mean, this is just this. This is, even if we were trying to fake it, we couldn't fake it. So this is really the company that we are, fostering and building. And because of this, we feel that all of our challenges are within reach because we always have a breadth of experience and a breadth of knowledge that's helping us take that next step.
Absolutely. So I wanted to give you just a glimpse into what it's like to be a spacecraft operator. For those of you who are in mission operations, and you know this super well, but the day of an operator, I guess it can go a lot of different ways. But at the core of it, we are responsible for instructing our spacecraft, commanding them, telling them what to do so that we can actually meet our mission goals and get to the moon. We're also responsible for monitoring their health and safety. In this picture here, you can see on our monitors, there's a lot of colorful plots and graphs and numbers and data. And this is the core of what we do. Because as much as I would love for there to be a nice selfie stick and for the spacecraft to come with an AI to explain everything that's going on with it, that's not the case. Instead, as operators, it's our job to take in all of this data of the different subsystems and interpret that to understand what's actually going on. And this being a maiden mission, and this just being space in general, because, I mean, we're not here because space is easy, right? We're here because space is challenging, and that's what makes it interesting. So we knew that there would be unknowns that we would face, and we were prepared to handle these unknowns like operators. We basically function as a team to be able to quickly and logically be able to tackle what we might not understand. So we're 135 days in space. That's 135 days of opportunity to learn something new about your spacecraft, right? So maybe Fede can tell us a little bit more about how we tackled anomalous situations and how we prepared for them. Honestly,
yeah, it was quite an impressive experience because I had the luck of being able to contribute both in Luxembourg and in Tokyo, and the approach that the teams were taking. So many of us actually, this was the first space mission, which means that we were learning as we were going. So communication was key, collaboration, trying to solve problems together. So all of these things that are nice buzzwords and sometimes you just like to talk about it, actually implementing it might not be as easy as it comes. So we became a unit. We became one working unit. And this is the same both for Luxembourg and Tokyo. So actually what you see on the slide here is the facility in Luxembourg performing backup operations. So we were asked, as you said, it's near impossible to have no anomalies in the first mission. It's the first mission for the team, for the spacecraft. So it was decided that the company would invest in a mission control facility that could take over certain operational duties in the event of a downtime in Tokyo. So say that the operators could not connect from Tokyo for whichever reason, then we would be ready and we would jump in and monitor the spacecraft or assume command until the original command is restored. So even just saying that out loud feels a bit over the moon. It just feel like how can we even work on something like this? How can we deliver something like this? As well as unfortunately this was during a challenging pandemic time. So supply chain management, trying to procure things, the relationship with suppliers. This was already in itself a challenge, and it added on to it. So I'm extremely, extremely proud to have been part of the teams that were able to deliver this facility and not only have it ready, but use it. So actually use it in flight and start to validate some of our procedures, processes, workflows, even things like the hardware, the headsets, simple things, but this gives us much more maturity and confidence for the missions in the future. So M2 and our roadmap as well.
Exactly. And like you were saying, of course, there's an expectation. You must have the expectation that you're going to encounter something when you're out there in space, when you're doing a mission like this. And what happened with us, since we took a low energy transfer orbit, it meant that we were going to need to be able to sustain ourselves in space for 5 months. 5 months. That meant weekends, holidays, middle of the night, early in the morning, we were coming to this mission control center and getting on the train with everyone else after doing something incredible and just trying to contain it in
Someone
yourself.
Had a child? One of our team members had a child?
Multiple people had children during the mission. I mean, it's an incredible time because it's like you can't really separate your life from the mission itself. And as a result of spending so much time in this room and spending so much time with these people, we naturally became experts at our craft. We knew the ins and outs of our spacecraft because we were there with it every single day. I mean, I started this mission when I was, 28 years old. I'm 29 now. I moved to a new country, And look at how much happened in that point of time. It's incredible, an entire mission. And to be able to take in the role of a flight director leading these problem solving has just been incredible. And this also resulted in us becoming masters of our spacecraft. I loved maneuver days. Maneuver days are very critical. This is how we stay on course. This is how we get on the trajectory that we need in order to be able to land on the moon. And we would come into this room, we would meet right in here, and we have all the engineers who would sit on console, come around here, and basically explain and report about the status of their subsystem. Are you go for the burn? Thermal, prop, software, Avio, Spacon, go, 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 go. If I hear all goes, we're ready for the burn. And we were able to do this 7 times successfully, including a critical maneuver, the lunar orbit insertion. And boy, watching for 10 minutes, that was an incredible moment right there to see our burn happen and put us into lunar orbit. And the result of our work is not like this intangible thing. This picture that you're seeing right now, I remember the day that we got this picture. I was sitting in the mission control.
Same, yeah.
And we had, one of my colleagues was in the back room, and he was downloading this picture, he was processing it. He said, everybody, come back here, come back here. We came to the back, and we're like, oh my gosh, it's an Earthrise, right? An Earthrise. And you look even closer, do you see that black dot on the Earth? That black dot turned out to be a solar eclipse happening over Australia. And we captured that in this picture. That's incredible. This is a one-of-a-kind thing. It really doesn't get any better than this. And then, oh man, look at this video.
Yeah.
This was our wake-up call that we're there. I mean, we knew we were there. We saw the telemetry. We saw the data. We did the burn. We knew it was good. But this was really screaming to us, we are at the moon. Really special stuff. Now on to the landing. You've been on this journey with us. We're 5 months into operating this spacecraft, and we've earned ourselves the chance to go for landing. In this picture, I actually think you can spot me and Fede. Fede, are you in here? Where are you?
In the middle.
Oh, yeah. You can spot me and Fede in this picture.
Pretending to be focused.
Pretending to be focused. And this, I want to tell you, was really special for us. If you had tuned into the live stream, when you tuned into this moment, seeing us in the Mission Control Center, you actually saw us when the hard work was done. Our hands were in the air at this point. There was no driving the spacecraft. The spacecraft was going to start its own autonomous landing sequence, and we were going to watch along with all of you. And what you may not have known, though, is that 16 hours prior to this, we started the process of getting our spacecraft ready for this moment. We had so many parameters to ready. We needed to check our burn plan. We needed to confirm that it was good. We needed to have products uploaded. We needed to be absolutely sure that we gave our spacecraft the best chance possible to go for this landing. And after all of that hard work was done, we waited in anticipation, because what was going to happen next was a maneuver or a burn that was going to be non-visible to us. That was because of just the natural order of things. Essentially, the moon was in between our lander and the antenna on Earth, which meant that we were going to lose communication when it started its deorbit process. So we watched along with you all to see ourselves pop up the other side to see if we had communication, and we did. We did. And then, if you were watching along with us, you may also know the results of this. We were watching the data in the Mission Control Center with bated breath to see if our autonomous sequence would take us to the landing. And unfortunately, in this first mission, we didn't get all the way there. We like to say that it was 99.9%. It was so close. We were able to slow ourselves down, and we were able to go in the location that we planned for, but it just didn't work out all the way. The really incredible thing about all of this, though, is that we got all of the data. So we didn't have that soft landing on the moon, but we got something extremely valuable out of this experience. Not only did we get those 5 months of learning, but we also got to understand and investigate and learn what went wrong. And as a result, that meant that we would know how to do better the next time around. It's a really special thing. Sometimes you crash and you have no idea why. That's a real bummer. So we're really grateful for that at the very least. And if you want the whole analysis about what happened and this and that, you can definitely check out our YouTube and press release to get more information. But what I do want to say and what I do want to show you is that we saw your support. And you really, when you're on console like this and you're not sure, when you're on console and you're not sure what's going to happen and you're just hoping for the best, because that's all you can do at the end of the day once we got to this place at least. We gave it our all. You don't know how it's going to feel if it doesn't go all your way, right? But I will tell you that being able to read comments like these, going home to text messages, calls from loved ones, family, friends, complete strangers. Even I met a lot of you at this conference today who came up and told me that you supported us. And you have no idea, like, how much that means to myself, our team, and the encouragement it gives us for what comes next.
Indeed. So you might be wondering, we've taken you through the M1 mission, the successes, the challenges, the teams coming together. So what is actually happening now? What is coming next for the company and for our teams? So we have two missions which are manifested. We have the M2 mission and the M3 mission. So the M2 mission, which is planned for launch next year, will be still using the Series 1 lander, modified and improved based on the lessons learned from M1. And we'll take a new suite of payloads, so instruments to the surface, including our micro rover, that I will talk about in a second, and other payloads, including a deep space radiation probe, so we can monitor the radiation coming, hitting the spacecraft, a algae monitoring probe, so we can try some biological experiments on board, and as well as that, a water electrolysis equipment, so that we can start testing some of the future roadmap technologies we will need for future landers and rovers as well. Then the mission 3 is planned for 2026. This will be no longer in fulfillment of the Akuto-R program, but rather the NASA CLIPS program. And it's been worked on by the Denver office using the new lander design that we have presented, we have introduced to the world recently, Apex-1. And we will also, as part of the mission architecture, deploy a number of satellites in lunar orbit to support with a communication relay. So what I'm trying to communicate here is that you can see with each mission, we try and add a little bit more. So this is the natural roadmap and progression of the company. We try and make it a little bit more complex each time so that we can fulfill the ambition and the vision. And this is the proof of it. So regarding M2, which is the next thing that's happening, so we have the flight model assembly, which is taking place right now. You can see a bottom panel that's being assembled and integrated at the moment with some of the harnesses and cables. And then some of the team members, a fun fact you can see on the picture, there is a statuette that's being held by the team members, which is called Daruma. And this is Japanese tradition for, perseverance, good luck, and leaving a wish. So how does it work? You have a wish, you want to achieve something, you have a dream, you have a vision. So you fill in one of the eyes of Daruma, and then you persevere. You show resilience, you work hard, you keep working, you deliver on that vision, and then Daruma gets the second eye, which means Daruma's vision is finally restored and can be part of the ambition as well. So I think it's really nice, not just because it's nice in general for personal life, professional life, but for iSpace where we are today. This is what we need. This is the emotions that we need to carry with us, the level of performance that we need to carry for M2 forward. So it's really resonating with me, and I'm sure with the rest of the team members as well. It's I quite like it, quite enjoy it. And last but not least, so we will have a Luxembourgish rover flying to the moon next year, and then landing and operating the following year. So even just putting the statement together, when I joined the company, I thought I would never even speak it once. So it's really fantastic. It's really astonishing to see how far we've come and how much work has been put into this. The team members have come together from multiple places in the world. We had to go through challenging pandemic times and other things. So really to see this, as a real product that exists and will actually operate and perform its mission, it is a huge, huge deal, personally and also for the white teams. So we try to make it for the first, this is just one of our rovers in the product line. It's not the only one we're working on, but it's the one that will take the M2 mission. And we try to make it as light and compact as we could. It's about 5 kilos by itself, and together with the payloads as well that we're going to fly, we are going to culminating in fulfilling some missions for our customers, including the NASA Regolith Collection mission, which is something we signed in recent years as part of a Space Resources Initiative to collect regolith from the surface and transfer the ownership from NASA, to NASA. So what this means is that even though the scale of the contract, the scope is still small and limited, this is the first of its kind. It will be the opening door for such ecosystem and such transactions to take place in the future. So we are looking forward to that taking place. And how will we do this? We will do it with a scooping device. It's not very well seeable here. It's on the panel behind, but it's a scooping end effector that we worked on with our partners at Epiroc. Epiroc is a Swedish company, world leader in mining and infrastructure equipment. So they have joined us on this journey like 3-4 years ago now, and we are excited to take them to the moon and perform this experiment together. So to end it here, honestly, on a professional side, it is truly remarkable what we get to do on a daily basis. The people that we work with, the missions that we're part of, the learning opportunities, and what we can bring to the Luxembourg ecosystem as well. This is, almost doesn't need any introduction. But personally as well, honestly, I joined when I was 24. I was a young graduate. Now I'm married with a child. I've it's amazing. Thank you very much. I've driven a spacecraft. Like even just coming out of my mouth doesn't feel like reality. So I'm so proud and so lucky to be part of this team. And a big thank you to VLSA and ESA for letting us do this work and trusting us with these projects and making sure that we can work, without worries. We are going to get to the moon together, and we're going to do it soon.
Thank you.
Let's give it up loud. Janelle and Federico. Wow.